Imagine a classroom where each student gets exactly 2 minutes of time to talk and the turn passes to the next. This is exactly how round robin scheduling works in your CPU. Dive in to get a complete breakdown of the round robin scheduling in operating systems.
Round robin scheduling. Round robin scheduling is a preemptive CPU scheduling algorithm where each process is assigned a fixed time quantum. Processes are scheduled in a circular queue. And if a process doesn't finish in its time quantum, it is moved to the end of the queue. Imagine this as a circular queue where P1 is the first process and P8 is the last process. So, if a process P5 that doesn't get ended in its given time quantum, then it is moved to the end of the queue. Key point of this scheduling is it is one of the fairest scheduling techniques because every process gets an equal share of CPU time. To understand the round robin scheduling, let's see an example. This is an example where we have 5 processes P1 to P5 and their arrival times are from 0 to 4. They have their unique burst times and the time quantum given is 2. We have to find the average turnaround time and the average waiting time. So to solve this problem, the first step is to draw a Gantt chart. So this is the Gantt chart for the given problem and let me break you through how this Gantt chart has been made. To draw this Gantt chart, we have to always note and keep track of the ready queue and the timelines. So, at timeline 0, P1 arrives. So, P1 takes the CPU. Since P1 is taking the CPU, no other processes can come here and P1 can run till timeline 2 because the time quantum is 2. And at timeline 1, P2 arrives. But P2 can't be given the CPU because P1 is still running. So P1 continues. And at timeline 2, P1 is preempted with burst time 3 and P2 is given the CPU. Then P3 is also arrived. So the ready queue at timeline 2 will look like P3 and P1 is preempted with the burst time of 3. So the ready queue can also be drawn for the timeline 1 where P1 is still running in the CPU and P2 is waiting. So let's move on to the timeline 3. At timeline 3, P2 continues its execution and P4 arrives at time 3. So the ready queue of this looks like P3, P1 and P4. We should always note that the process that arrives at a particular time will always be in the head of the ready queue and the process that has been preempted will always stay in the tail of the ready queue. And the next process will be added to the next of the ready queue. Then at timeline 4, P3 will get the CPU because it was in the head of the ready queue and P2 has been preempted with remaining of 1 burst time and P5 arrives. So the ready queue at timeline 4 will be P1, P4, P5 and P2. And at timeline 5, we have to note that P1 from the queue takes the CPU because it is there in the head and there is no new process that arrives. So the process continues as per the timeline. And at 6, we have to note that there are no new processes and P1 continues to stay in the CPU. At 7, P4 takes the CPU because P1 can run up to 2 quantums and then P1 is again preempted. So the ready queue will look like P5, P2 and P1 since P4 already got the CPU. Then let's move on to the timeline 8. So at timeline 8, P4 continues its execution and at timeline 4, P4 continues and is removed from the CPU. So P4 is completely executed. Then P5 takes the CPU. So the ready queue here looks like P2 and P1. At timeline 10, P5 continues and at timeline 11, P5 is preempted and P2 takes the CPU. So the ready queue looks like P1 and P5. Then at timeline 12, P2 is completed because it only had 1 burst time when it got preempted. So it got completed. Then P1 gets the CPU. So at timeline 12, the ready queue will look like this. Then at timeline 13, P1 completes and it is completely removed from the CPU since its execution got over, and P5, which is the last process that takes the CPU, and P5 starts its execution. At timeline 14, P5 is completed. So all the process has been executed with its own time quantums. So by this, we had drawn the Gantt chart. So the second step is to find the turnaround time and the waiting time. Turnaround time can be found by subtracting the completion time and the arrival time. We can get the completion time from the Gantt chart, where for process 1 it is 13 and for process P5 it's 14. So like this, you can get the completion time from the entire Gantt chart, and the waiting time can be subtracted from turnaround time and the burst time. So using this formula, I have already taken and subtracted their values and have already given the values here. So the third step for us is to find the average turnaround time and the average waiting time. So the third and fourth steps are as: for average turnaround time, we have to add this and divide by 5 since we have 5 processes. So the average turnaround time comes as 8.6 units, and the fourth process, that is the last process, that is average waiting time, comes of 5.8 units. So like this, you have to solve the given problems for round robin
Now
scheduling.
I'll be explaining the round robin scheduling algorithm simulator, which is built using Java Swing here. So this program basically provides a simple GUI tool to stimulate the round robin CPU scheduling algorithm. The user can the user can enter the process name, burst time, and the arrival time and set a proper quantum time. They can add the process into the tabular column that is built here. And after adding all the processes, they can compute the schedule. So as a result, a table will be formed along with the completion time, turnaround time, and waiting time that is calculated, and a Gantt chart that will visually represent the execution order and the time slices of all the processes in according to the time quantum. So as a result, along with this, the average waiting time and the average turnaround time will also be executed. So let me run this code for you. I've already added 3 processes into the table. For now, let me add the 2 more processes, like the process arrival time, and let me set this is the example that has already been explained priorly in the video. So I'm using the same data. So for the burst time of process 4, I'm adding 2 and adding the process, and for process 5 the arrival time is 4 and the burst time is 3. Time quantum remains the same for all the processes. So all the processes have been added, and now we can compute the scheduling. So now Gantt chart has been generated according to the data that is given. So process 1 to 5 is all been executed. So you can verify this from the previous where this has been explained. And the average waiting time, which is 5.8, and the average turnaround time, which is 8.6, is also generated. You can also use the clear button to clear the data. So this code, the main usage of this program is to help everyone understand how round robin scheduling works in operating system, and also explain how easily it can be stimulated through coding. This demo helps how preemption occurs and how quantum expires and how metrics like waiting time and turnaround time are calculated. So the tool demonstrates the process scheduling in an interactive and visual method. So as a result, we've obtained this result output.